Welcome, students. Please keep yourself tuned in for the fifth edition of Lead Masterclass. We'll be going live soon in a couple of minutes with Mr. Debapriyay Mukhopadhyay, your instructor for the mental math session today. In the comment box, students, do tell us how excited you feel about today's masterclass. Mr. Debapriyay will be telling us how to have some fun with maths and how to solve maths problems more quickly. So stay tuned in for exciting session ahead. Thank you. Hello, everyone. Welcome to the fifth edition of Lead Masterclass. This is your host for the day, Himanshu. At Lead, we ensure that our students should not only be equipped with excellent academic education, but also with the skills that help them to succeed in life. Maths can be fun too if students can relate it to real life and are taught in a fun way. To remove the fear of maths in students, we are presenting a Lead Masterclass on mental maths. Mr. Debapriya has founded the blog Ganit Charcha, and under the umbrella of Ganit Charcha, he and his team work in popularizing mathematics amongst young school-going students. He has been a corporate professional for the last 20 years and is currently associated with Bayer as a senior product manager and is working in developing solutions for cyber defense. Sounds interesting, right? Now, kids, without any further delay, let's hear it from Mr. Debapriya. Mr. Debapriya, over to you.
Thank you, Himanshu, for this nice introduction. Uh, Good morning, everyone. So we have seen last day that how mental maths can help us do things better. We have at least tried to appreciate. We have tried to understand that why mental maths could be very much useful in your life. Uh, it's not
Um,
only just because of
Mr. Devapriya, sorry to
real life.
interrupt you, but your video is not visible. Could you please check this on your end?
But video is already on from my side. I have not stopped it. Can you hear me basically?
Yeah, I can hear you, but can't see you.
My camera is on. Can you see me now?
No, we cannot. Maybe you can try joining back again. That's a possibility.
Okay.
Sorry, students. I think it's some technical glitch. Mr. Devapriya will be joining back. Yes, we can see you now, Mr. Devapriya.
Yeah. So sorry for the interruption. So let me get started with what I have shared earlier. Basically, we have uh, already seen in last day session that mental maths can be used in different areas of life. It helps, but apart from that, it also helps in your competitive examinations, your in your day-to-day uh, examinations that you need to give in each class. So it helps in building your mental math competencies. Not only just that, it helps in building your way you think about mathematics, the way you try to solve problems, the way you try to attack problems. So all these things are related. So without going into the same thing once again, let me just get ahead with today's presentation and see what we can uh, learn today. So just a recapitulation of whatever we have gone through. We have already gone through in last session that numbers are important, and why numbers are important. We have already appreciated that it starts helping us with the counting, and then helps us measure and quantify, and different other things that we can do, like comparing, ordering, and the most important thing is basically it helps us to uh, model the human actions, so that there are different human actions which you can model using uh, operations defined on numbers. So addition, subtraction, multiplication, division are all uh, operations defined on numbers. So we'll see additions in uh, more detail. We will see that how we can handle problems of addition mentally and quickly. But it is not just learning the skill. All you need to do is to practice each and every skill more and more. Whenever you encounter certain problems in your school setting or in your day-to-day life, you will try to utilize these skills, or you would try to utilize all the tools that you have learned. More you try that, more confident you will be, more faster you will be in handling all these things. So we have seen an important concept in last day's session, which is place value. So keep that in mind, because that will be used too often in today's session also. So I will refer quickly the place value system. So we started the discussion of place value system by just asking you a simple question, that what you call 1 to the number. When you see 1 2, the integer 1 and 2 put together alongside, so what will you refer that number as, whether it's a 12 or whether it's a 21? So you came up with the answer that it will be 12. And later on we have seen that each and every place where integers are placed has got certain value associated with that. So that's your place value system. So now we will get into the today's main session. So Himanshu, can you please go to the next slide? So it's a simple question. You have 4 chocolates and you got 11 more from me. What is the total number of chocolates you have now? So total number, this part is highlighted. Why this part is highlighted? Because these gives you an indication that what kind of operations that you need to do, what kind of how you should think of solving this problem. You know that it's a basic addition problem, uh, but who are just uh, starting with mathematics, who are just started solving the word problems on mathematics, for them it is not that easy to find out that what operations they need to do over here. So this total number is highlighted uh, for that. Total number is helping you or signifying you that it is asking you to do an addition operations on the two integers mentioned in the problem. So the two integers are basically, one is 4 chocolates and another is 11. So these two numbers that you have, 4 and 11. So while you will see total in any number problem, you will automatically try to signify it as an additional problem. So given this, how will you try to solve this problem? If I ask you to do it mentally, what approach will you take? So just a
Sure.
rough thought, just to, I will just give a thought to this simple problem uh, to help you understand. So in the next slide, we will see a number line. Yeah. So this number line is basically a straight line, and integers or numbers are plotted on these uh, line at equal distances. So you can see that on the left hand side, we have 0 mark, and then we are slowly progressing towards 20 at the end. So that's how your number line is defined. It can be extended to any number of uh, points, or it can be extended to 30, it can be extended to 40, it can be extended to 50, and so on. But since for this problem we don't need more than 20, so I have kept it in this picture, just from 0 to 20. Now, what will be your strategy to solve this problem? The problem that I have stated in the last slide, that you have 4 chocolates and you have 11 more chocolates you have got. So what will be the total number of chocolates that uh, you will have now? You all know the answer. You already have computed the answer. But I want to know from you that how will you solve this problem given this number line? What kind of thoughts are coming into your mind when you see these number line, when you are seeing this number line, and when you have given the problem in the last slide? I just wanted to hear from you first.
Sure, students. So I think what Debapriyay sir is trying to ask is, what will be your strategy? What would be your thought process in order to, uh, do this particular computation? So, Mr. Debapriya, a lot of students have actually computed the answer and have typed it in the comment box. So, Archana Dande, for instance, says that it's 15. Ashwani Mane says that it's 15. Pinky Gautam says that it's 15. Manoj
Yeah,
Kumar
the
says
answer
that
is
it's
correct.
right. Manoj Kumar says that it's 4 plus 11 is equal to 15.
Yeah, yeah, it's correct. The answer is 15, and they have already figured out that the addition we are required to perform in this case. So 4 plus 11 is 15. Uh, that's the right answer. But it's not just about solving the problem. It's not just about coming to the right answer. We should also learn in the process that how should we think. So this question is specially aimed to aim for that, basically how we can think. So just if you have to count it mentally, then what you can do, you know that you have 4 chocolates, and then you have got 11 more chocolates. So you can add 11 uh, with 4. Now in this number line, you can mark at 4 first, because you have 4 chocolates. And then what you can do, you can, from 4, you can count 11 more sticks to come to 15. So that is how you can get 15 just simply by counting. We start to solve addition problems first by counting. So this number line is to help you with that counting. So you can mark 4 and then can count 11 from 4. That means starting from 5, and then you will get to 15. So that's one way of solving it. But you know that you have been given two numbers. So one is 4 and another is 11. So we can even start by marking 11 because you know that you have got 11 more chocolates and you had earlier 4 chocolates. So from 11, you can mark 4 more sticks to get 15. So these are the two ways you can think about solving it in the number line. So 4 plus 11 is equal to 15. In a similar way, 11 plus 4 is also 15. So what I wanted to show here, you have already learned how to compare. So you know that 4 and 11 are two numbers and you can compare 4 and 11. So 11 is greater than 4. So since 11 is greater than 4, that means I should start with 11 because while counting, I need to count less because the other number is lesser than 11. But if you take the other way, so you start with 4, so that's the lesser number, and you have to count more. That means you have to count 11 afterwards from 4 to get to 15. So these type of thoughts are helpful. Even this strategy holds true for subtraction. This strategy holds true for subtraction. You have to adjust the strategy, that how you can adapt this strategy to come to the conclusion mentally or to come to the answer mentally. So this is the key takeaway from these simple problem, that how you can start looking at a very simple problem or looking at a problem which you know that you can solve very easily. Now I will go to the next slide. So there is a technique called manipulation. So I am going to explain these technique uh, with the help of the previous problem, which is pretty simple, but still it will be useful for me to help you understand this technique uh, with this simple exercise. So you have already learned place value system. So you know that 11, if we expand in terms of place value system, then it will be 10 plus 1, because 1 is in the tens position and 1 is in the
Mr. Debapriyay, I cannot hear you. I think there's some glitch I feel that we are having. Can you try to unmute yourself and then unmute? No, still cannot hear you.
is also in the
Yes,
ones position.
can hear.
Since 1 is in the tens position, is equal to 10, and then we have to add it with 4. 10 is there, and there are two. One is 1 and another is the 4. The strategy is talking about to figure out or separate out the 10. So how many tens? 11 as one operand. So I can separate out. Can
Can hear you now. Can hear you now, sir.
can you hear me now?
Yes.
So what I was talking about is basically these technique called manipulation, where we need to search for 10. So we need to separate out from the operands the number of tens, the maximum number of tens that we can separate out easily from the system. So since 11 is one operand, so we can write it as 10 plus 1. And another operand that we have in this problem is 4. So there are two one digit numbers which are like hanging. One is 1 and another is 4. So what you can do, you can add these two numbers 1 and 4. So that will give you 5, and that's simple. You can do it mentally very easily because adding 1 is like finding out the after number of 4. So you have got 5, and you have already separated out one 10 from the integer 11. So it's a simple problem, simple technique in the small problem. But if you do calculations like 89 plus 3, then you can probably associate that. So 89 plus 3 or 89 plus 4. So you can write 89 as 80 plus 9, and you have now 8 tens already separated out, which is 80, and then you have 9 and 4. So you can simply add these one digit numbers 9 and 4. So that will give you 13. So 13 is again a two digit number which will have uh, 110. So 10 plus 3. So you have earlier separated out 110, 80, 8 tens, so 80. And now you have separated out another 10, which is 110. So 8, 10, and 110 put together will be 9 tens. So it will be 90 plus 3. So that will be your 93. So 89 plus 4 is equal to 93. So quickly you can do these processes. So that can be extended to hundreds, that can be extended to thousands too. Now let's come to the next slide. Yes, this is a simple, another simple exercise which we will try to do over here. So 8 plus 6 is equal to how much? So you can see that I have created two uh, tables or two buckets of 10 each. So in one bucket, I have marked it as 8 red crosses. And in another bucket, I have mentioned it with 6 yellow crosses, which are basically the operands or the numbers that I have. So how you can quickly come to make a 10. So if you see that in the out of 8 and 6, 8 is greater, and you can also visualize from the picture here that in the first bucket there are two cells are which are empty, and in the bottom bucket there are four cells which are empty. So if I can take two of the yellow crosses from the bottommost bucket to the topmost one, so that will fill up the first bucket fully. So that means you will have a complete 10 there, and something will be remaining in your bottommost bucket. So let's see in the next slide. So in the earlier example, we have seen that 8 plus 6 we have to add. So you can move two of the yellow crosses from the bottommost one to the topmost one. So that will make it a 10. And what you are left with is basically four yellow crosses on the bottommost bucket. So you have completed 110 in the one bucket of tens in the uh, topmost bucket. So that is your 10, and four remaining in the bottommost one. So 10 plus 4 is equal to 14. Now there is another way you can solve this problem. So that's two apart addition fact. So two apart addition fact means these trick or this strategy is only applicable for two numbers where two numbers are just separated by a number called 2. So that means the difference between the two numbers is 2. So it applies to the earlier example 8 and 6, because 8 minus 6 is equal to 2. So that's where you can apply this trick only. So two apart, the two numbers are uh, just two integer apart. Now, one way of solving this is double the smaller number. So you can double the smaller number and add 2 with that. So you can see in the earlier example, the smaller number was 6. So you could have doubled it. So doubling means you have to just multiply it with 2. So 6 into 2 is equal to 12. 2 6 are 12, or 6 2s are 12, whatever you call it. So 12, and then you can add 2 with that. So that will give you 14. So 12 plus 2 is 14. And another way of doing it is double the number in between. So 8 and 6. So what is the number which you have in the in between? So we have uh, solved problems like between numbers. So the between number between 8 and 6 is 7. So you can just double the between number. So you can double 7. So that will give you 14. Now this is an example for you. So 7 plus 9. So the smaller number is 7. So you can double that and can add 2 with that. So 2 into 7 is 14. And you can add 2 with that. So 14 plus 2 is equal to 16. Or else you can find out the between number. So between number here is 8. And you can double the between number. So 8 into 2 is equal to 16. So this trick is very useful. Only thing you need to look out for is to find out whether the two numbers are just the difference between the two numbers is just 2 or not. Now we will go to the next slide. Now this is another thing that I have talked about, that the place value system can be extended to uh, trick of searching for 10, which we have seen in earlier example. So this is very handy, and you can very easily apply that. So you know that 5 plus 1 is equal to 6. So since 5 plus 1 is 6, so 50 plus 10 is also 60. Just 10 is added in the ones place. If I add two zeros in ones place and tens place, so that makes it 500 and 100, then it's 600. So you don't need to bother much. You know 5 plus 1 is equal to 6. So 50 plus 10, 500 plus 100 is equal to 600. So these things can be easily computed. Now, how in the earlier example that I talked about, 7 plus 9 is equal to 16. Uh, so we can easily extend that fact to a bigger number. So 70 plus 90 is equal to 160. 700 plus 900 is equal to 1600. So what I wanted to show here is 7 plus 9 is equal to 16 can be solved using two apart fact, but 70 plus 90 cannot be solved using two apart fact, because these two numbers are not just having a difference between each other as 2. Similarly, the difference between 900 and 700 is also not 2, it's 200. So you cannot apply that trick. But you see that you have consecutive zeros at the end, so you can strip it out mentally and can easily see that 7 and 9 uh, is the single digit number of 7, and can just simply append the number of zeros you have stripped out. So 7 plus 9 is equal to 16, and in 70 and 90 you have stripped out 1 zero. So you know that your result is 160 when you add 70 plus 90. In 700 plus 900 you have stripped out two zeros to get 7 plus 9. So you know that you have to add two more zeros at the end of 16 to get the result, which is 1600. So this is how you can extend the tricks for tens and hundreds. Means while you are working with higher numbers where you have more number of tens, where you have more number of hundreds, where you have more number of thousands and all. Now we'll see in the next slide. So in this case also we will see something using place value expansion. So how we can solve this problem: 353 plus 471. Now 353 can be written as 300 plus 50 plus 3 in your place value expansion system, and 471 can be written as 400 plus 70 plus 1. Now you can group the hundreds, you can group the tens, and you can group the ones. So you have 300s and 400s in the two numbers that you are required to add. So just what I have covered in the last slide. So you simply can add 3 and 4. So that's 7. And you have to make it 700, because that's your 300 plus 400. And then you have 550 plus 70, so which is nothing but 5 plus 7 is equal to 12, and then you have to add 10 with that, so it's 120. And then the two single digit numbers are 3 and 1, so you have to make it 4. 3 plus 1 is 4. So now you have to add 700 plus 120 plus 4, uh, and 120 you can again expand it using place value system. That will make it 100 plus 20, and at the end you will have 0, so you don't need to write that. So 700 plus 100 plus 20 plus 4. So that's the next thing that you are doing. So you have got one more 100. So put together these two hundreds, one is 700 and another is 100. So you get your 800, and then you are left with two tens, that's your 20, and four ones, that's your 4. So 800 plus 20 plus 4 will give you 824. So the more you practice, more quickly you can do these things quickly on your head. It is not that difficult, but only thing that is required is uh, doing it over and over again. Now we'll see in the next slide. So the same exercise, how we can think about it in different other ways. So that's what has been explained. So 353. Earlier, what we have done, we have separated out hundreds, we have separated out tens, and we have separated it out ones. While doing that, we are simply taking help from place value system. So we have written 353 as 300 plus 50 plus 3. So this time, what we are doing, we are just separating out ones and keeping aside all the things as it is. So it becomes 350 plus 3. And for 471, it becomes 470 plus 1. Now 350 plus 470, you have to add. So 350 plus 470, you can add in the same way. So it becomes your 3 tens, and then you have your 5 tens and 7 tens, or 300 and 400, and then you have 5 tens and 7 tens. So that's the normal way of doing it. It's basically 700 plus 120, and you get your number as 820. Here it is written mistakenly as 840. It's a typo. So don't give much attention to this number. It will be 820. And then you have your 4 remaining. So 820 plus 4 is equal to 824. So apparently it looks the same, but it's while you apply it, it can have some added advantage. So the more you practice that, some of the times you will see that you just don't need to break it into full place value system. Halfway doing it might help you solve the problem in a quicker fashion. So that's why I have written it over here. Now we will see in the next slide. So this trick is called compensating. So let's see what it is. So here we have also two 3-digit numbers to add. So one is 399 and another is 467. So you see that 399 is just one short of 400. So 400, if I can make it, so that makes my life easy. That makes my job easy, because I'm in search of tens, or I'm in search of hundreds. So 400 is making it a whole 100. So I'm successful in searching my 100. Now 400 I can add easily with 467. So that will quickly make it 867. And since I have already added 1 with 399 to make it 400, so I have to subtract, or I have to take away 1 from the end result. So I will just simply take out 1 from the end result, which is 867. So that's just finding out the before number of 867. So what I get is 866, and that's the result of this addition. So 399 plus 467 is equal to 866. So this is what is called compensating. So you first add something with any of the operands to make it a 10 or 100 or 1000, and then you know that you have simply added 1 or 2 or maybe 3, some 1-digit number, and just you take that out from the end result to come to the right result of the addition. So that is why it is called compensating. Now let's see in the next slide what I get. So the same exercise. So this strategy is called give and take. So earlier it was compensating, and now this trick is called give and take, and it is being explained with the same exercise or same problem. So 399 plus 467. So here we also do the same thing, but instead of uh, adding simply 1 with 399, and then adding the other number, which is 467 with 400, what we are doing, we are just taking out 1 from the other number and giving it to the other number. So we have taken out 1 from 467 and we are giving it to 399 to make it 400. So the moment I give 1 from, by taking 1 from 467, my first number becomes 400, which is 399, and my second number, which was 467, becomes 466, because 1 has been taken out from 467. So now you have 400 plus 466, which is simply 866. So you don't need to add first and then take out 1. Rather, from one of the operand, you can take the number which you require to make a wholesome 400 or 1000 or 10, and then you can add the two numbers. So this strategy is called give and M.Tech. Now I will see in the next slide. So we have seen compensating and we have seen give and take. Now this is a combination of the two. So it's being explained with another example, which is 394 plus 414, 414. So what we have done here first, basically, we have taken out 14 from 400, 414, 414, and we have given 6 from 14 to 394. So by doing this, we have got 400 plus 400. So which is very simple to compute, that is 800. So you have taken out 14, which was there with 414, 14, and you have given 6 to 394 to make it 400. So you are left with something. So that you need to compute what you are left with. So what you do, you just uh, subtract 6 from 14, because that has already been accounted, because you have given that 6 to 394 to make it 400. So you are left with now 8. So it's simple, 800 plus 8. So your result is 808. So this is called combination. Now I will see in the next slide. So you have a few exercises for you to solve. So you have seen two-a-part fact. You have seen how we can search for tens and hundreds to make my job easy to do additions quickly. We have seen compensating, we have seen give and take, we have seen a combination. And all these tricks can be applied for not just two numbers being added. It can be applied to more number of integers being added. So say for example, in this case, in the third example exercise, you have 361 and then 423 and then 105 to be added. So I want you to try these exercise and see and appreciate that how you can utilize the techniques that I have just explained, so that you can appreciate them better.
All right, students. So I think we have to try out this exercise by using the methods that Debapriyay sir has just told us.
I will go over each and every exercise, but I will first uh, ask you to give it a try. I can give 3 to 4 minutes time or 5 minutes time maybe for each of these problems to uh, try it out, and then we can go over each and every exercise.
Sure, Debapriyay sir. So come on, students, let's just try to solve this one with the methods that Debapriyay sir has just told us. So if you have to calculate and compute 83 plus 123, what is the method that you would use? If you have to calculate 298 plus 412, what is the method that you would use? And what would be the computation of that? So we're getting some answers, Devapriya sir. So
Yeah.
Ashwani Das says that for the first 83 plus 123, it's 206. He hasn't mentioned the method that he has used though, but
Yeah.
we have Priyanka Bini who says 298 plus 412 is equal to 710. We have Bhumika Thakkar saying for the 69 plus 89 is equal to 158.
Yeah.
We have Minakshi who's saying 151 plus 169 is equal to 320.
Yeah, each and every answer is correct. Now let me go over each and every exercise to help you reascertain that what we have just seen uh, has gone home. So 83 plus 123, you have done it correctly. But so 83 is basically 80 plus 3, and 123 is basically 120 plus 3. So two threes are separated out, so that makes it 6. And then you have 80 plus 120. Now you know that 80 plus 120 will give you 200. So that's 200 plus 6. So that's your 206. So this is a simple place value expansion, uh, which will help you to solve this problem quickly. Now, if you come to the next problem, which is 298 plus 412, so you can just go by compensating trick. So or give and take trick. So I will go by give and take trick. So I need to in 298 to make it 300, and I have 412, so I can take out 2 from 412 and can give it to 298 to make it 300. So it becomes now 300 plus 410, because I have already taken out 2 from 412. Now 300 plus 410. Now you can expand 410 as 400 plus 10. So now you have 300 plus 400, which is 700, and then you have 110 remaining with you. So that becomes your 710. So you can mentally compute it like this. In case of 69 plus 89, what you can do, you can see that if you can add 1 to each, so it becomes 70 and it becomes 90. So you just add 1 to each one of the two uh, numbers that you are required to add. So one is 70, now becomes 70, and another becomes 90. Now 70 plus 90, what it is? So 7 plus 9 is equal to 16, you have seen already. So it becomes your 160. Now you have to compensate because you have added 1 to each of the numbers. So that means you have to compensate with 2. So 160, from 160 you have to compensate 2. So it becomes your 158. 151 plus 169, it's the same one. It's basically give and take. You can take out 1 from 151 and can give it to 169. So it becomes your 170 and it becomes your 150. And 150 plus 170 put together will be 320. So that's how you can do it. Now I will come to the middle one. So 361 plus 423 and 105. So how you can do that? One way of doing it is through place value expansion. So 361, you can write it as 300 plus 60 plus 1. 423, you can write it as 400 plus 20 plus 3. And then 105, you can write it as 100 plus no zero tens plus 5. So you have 300, 400, and 100. That becomes your 3 plus 4 plus 1, basically 7 plus 1, 800. You have 6 tens and then 2 tens. That becomes your 8 tens. And you have 1, 3, and 5. Basically, 3 plus 1 is 4, and 4 plus 5 is 9 ones. So you have 800, 8 tens, and 9 ones. So that becomes your 889. So that's the simple place value expansion which you can take help of in order to solve that problem. But what is the other way you can think about solving this problem? Now you see, you can take out 1 from 361. So that will make it 360. You can take out 3 from 423 to make it 420. And you can add those things with 105, or you can also choose to take out 5 from 105. So then that means separating out all the ones. So 1, 3, and 5 put together is 9. And then you can think about adding 360, 420, and 100. And that will give you 880. And then you can add 9 with that. So that's your 889. So this is how you can approach these addition problems mentally. And if you practice each and every trick, say for example some 20 to 25 number of times, then automatically you will see that your thought pattern will be aligned in that way, so that you will prefer to add these additions mentally and in a much more quicker fashion compared to doing it on a pen and paper. It is required to solve problems on a pen and paper, but at the same time, these tools can help you validate whether your answer is correct or not. And you can do it mentally as well, and that too on a very quicker fashion. So that's what I have for today. If you have any questions, you can ask me.
Thank you, Mr. Devri. I think this was so enlightening. Let's take a small quick break. We are getting a tons of questions from students on the lead app. While we are running totally running out of time here, probably we can squeeze in like, two or three questions for Mr. Debapriyay. There are literally over thousands questions for you, Mr. Debapriyay, sir. We are getting a chat box right now. But in panel students, please do take out time to share your feedback on this masterclass. The link for the form is given in the description of this video. So please do check out the description of the video, and please do share your feedback by clicking on the link on the description. So we have a first question by Satyam. Can you please explain the compensation trick again, sir? Mr. Debapriyay, you're on mute. I think.
So can you please go back to the compensation slide, compensate slide? Yeah, by compensating, I mean I will add something to the to one of the operand, and then what we will do, we will do the additions for the numbers that we will get by doing that, and then whatever we have added to make it a complete 10 or make it a complete 100, and then we will take it out. So that's what is your compensating. Say for example, in this case, in this example, 399 plus 467. So you see that you have to add 1 with 399 to make it a complete 100. So which is your 400. So you don't think about anything. You just add 1 with 399. So that makes it 400. And in case of 467, you cannot make it a complete 100 or complete 10 just by adding 1 or 2. So leave it like that. So it's your 467. So you can simply add 400 with 467. That becomes your 867. Now you know that you have already added 1 with 399 to make it 400. So that means you have already given one chocolate, maybe more with 399 chocolates to make it 400. So you have to take out that. So that is what is called as compensating. So you are taking out 1 from 867 to make it 866, basically. So that means it's just computing the before number of 867. So this is what we call as compensating, because first you are adding something with the numbers that you are required to add, and then you are adjusting the result at the end by taking out some small integers, so for example 1 or 2, whatever you have added. In one of the exercise, we have seen that you are required to add at the last slide. So can you go to the last slide? Exercise slide. Yes. So in the fourth example, you see 69 plus 89. is how much? So you know that you can add 1 with 69 to make it a complete 10, which is 70. You can add 1 with 89 to make it a complete 10, which is 90. So you know that you have added 1 with 69, you have added 1 with 89 to both the numbers to make it complete tens. So one is becoming 70 now and another is becoming 90 now. So you have added 2 basically. So now you have added, you can add 70 with 90, so make it 160. So after you have made 160, now you have to compensate for what you have, whatever you have added first. So you have to compensate for 2 because you have added 1 with each of the number 69 and 89. So while you compensate 2 from 160, basically that is subtracting 2 from 160 and you get your 158. So this is what is called compensation, or this is what we call as compensate strategy in addition.
Thank you, Mr. Devapriya. So Hasini Bethani also asks, is it also same as give and take?
It's same as give and take, but not fully. I can explain it using the same example. 69 plus 89. So if I apply give and take, what it can become now? So I will take out 1 from 89 and add that 1 to 69. So I give 1 to 69 and taking out 1 from 89. So your new operands will be 69 plus 1 is equal to 70 and 89 minus 1 is equal to 88. So you have to add 70 with 88. So that's not that easy, adding 70 with 90. So you have to find out, you have to figure out that what strategy will be applicable where. But instead of having 89 there, if you are asked to add 69 with 91, then you know that you need to add 1 with 69 to make it 70, and that one you can take out from 91 to make it 90. So by giving and taking, by taking and giving, you can make both the integers become a complete 10. So 69 is becoming your 70 and 91 is becoming your 90. So then give and take will be more relevant, but not in this case. So there is a subtle difference between the two strategies. I hope you understand now.
I hope Hasini, Mr. Devapriya has answered your question. Thank you so much for that, Mr. Devapriya. While we would have loved to continue talking to you, Mr. Devapriya, for hours, we have really run out of time here. And thank you so much, Devapriya, sir, for sharing your journey and tips on mental maths. This will go a long way to help acquire one of the most important skills for thousands of students listening to you today. So thank you once again on behalf of all the students who joined us today for this live session. Uh, well, students, one important note, please do take out time to share your feedback on this masterclass. The link of the form is given in the description of this video. So please do share your feedback by clicking on the link which is mentioned in the description below. It is also pinned as a top comment in the chat box. So please go there and fill your feedback form. This will really help us to improve our masterclass for thousands of our lead students just like yourself. So finally, we have come today to the end of today's session. We hope all of us will start and continue our journey of improving our mathematics by practicing what Mr. Debapriya has taught us today. Thank you, everyone, and thank you once again, Mr. Debapriya. It has been a pleasure learning from you. Signing off from today's session. Goodbye and take care.